And yeah, welcome to reInvent. And thank you very much for joining us here. We actually got 2 upgrades today. First upgrade, we got a bigger room. Thank you very much for making this session so popular. And so many faces here. And the second upgrade is, this is the 3rd time we're doing this session together, Marcus and I. And we usually have to do this on Friday, 9 a.m. in the morning, right after the party, which is not the most popular spot, right? So thank you very much to the reInvent organizers for giving us a spot on Tuesday. So yeah, this is going to be jam-packed with advice here, so let's start right away. This is all about paying for your next trip to reInvent. So our goal is always to help you save so much money on your AWS bill so that the next trip, next year to reInvent is going to pay for itself. And so this is what we're going to cover here. We're going to cover some best practices on how to lower your AWS bill. But at the same time, this will help you to build a more robust, more scalable dynamic architecture. And it will also not only pay back in money, but it also pay back in time. You will gain more time to innovate and to really build something that is part of your company and not just reinventing wheels and wasting your efforts. We're going to learn from some real-world customer examples, and I have Markus Ostertag here from Team Internet. And most of the things we're going to talk about are going to be very easy to implement. So have your notes ready, take some notes, and then as you walk out here in about an hour, you'll have a couple of ideas that you can implement right away. We structured this talk in 3 levels. So there's going to be content for you business people out there. So who's a manager or who is kind of like more on the business side of things? Okay, cool. So stuff that you can talk to your manager about. Most of the talk is going to be about architecture, and we also cover some of the operational aspects here. So if you ask your manager about their business goals, then they will probably tell you, okay, let's pay as little as possible for what we use. These are the people that are always sitting on budgets here. And the good news is that you don't have to do anything. And you can save money by not doing anything, because it is part of our philosophy to lower prices all the time. Because whenever we reduce prices, we get to see more customers on our platform, which means we will see more AWS usage, which means we get to build more infrastructure. And that means that we can enjoy better economies of scale, which allows us to lower infrastructure costs. And our policy is to give those savings back to customers, which helps us reduce prices. There are 2 kickers here that accelerate this wheel. First of them is the more AWS usage we see, the bigger the ecosystem gets. More partners, bigger global footprint, new features, new services. And the second thing is, as we lower our infrastructure cost, we can actually do things in our infrastructure that other companies can't do because they don't have the critical mass. And a great example is James Hamilton, that last year showed us how we are building our own cable across oceans to optimize our network. So without doing anything, you're already saving money, because by applying these principles, we have reduced our prices 63 times since AWS got started in 2006. So who is already using AWS in some way or other? Cool. If you didn't lift your hands, your manager is going to probably ask you to do a TCO calculation. And we have a tool for that too. So you can go to the awstcocalculator.com website, plug in the numbers for your existing data center or colocation servers, and it'll give you a TCO study with all of the documentation that you need to help understand the cost on AWS versus the cost on premises. And these are not synthetic marketing numbers. These are real-world numbers from real analysts. And we give you all of the base data all of the assumptions and basic data so that you can tweak those assumptions and adjust to your actual usage and actual licensing cost and whatever. The other thing is that I would highly encourage you to set up your AWS billing alarms. This will give you an early warning if your AWS bill is reaching some predefined level, so that you get more visibility out of your AWS usage. And you get this even broken down by individual service. So you can always monitor your cost service by service and see if it is in line with your expectations. And another great thing, and this is something that has been upgraded and improved over time, is the AWS billing dashboard, which gives you every time great transparency on your AWS cost. And this is probably something very interesting for your manager. This is actually my own personal billing dashboard. And the other thing that I would like to encourage you to check out is the AWS Cost Explorer, which lets you drill down all of your monthly bills for the last couple of months and identify where are the biggest bits where you can save money. What are the services that, that create the biggest cost and where you should optimize first. So speaking of drilling down your bills, let's start talking to Markus here, because Markus is one of the biggest experts I know about drilling down into his own AWS bill.
Thank you, Konstantin. Is this on? Oh, yeah. So yeah, as Konstantin just mentioned, I'm Markus Ostertag, VP of Engineering at Team Internet. And as we have a lot of things to cover, I just want to go very, very shortly about who is Team Internet. We are one of the leading companies in the domain monetization business. We're only 35 people. Our headquarters is in Munich, Germany, and we are very, very tech-focused. So we're always trying to leverage tech as much as possible and scale only within tech and not with people. Costs are obviously a big thing for us. We need to make sure that we don't spend more than we actually need to. And that's why we're diving deep into our bill. And in our case, we're using Datadog for that. I don't want to emphasize so much about Datadog. It's more about that all your billing metrics are inside of CloudWatch and they are available to you. So for us, Datadog takes the job of pulling those metrics out of CloudWatch, and we build out a dashboard inside of our monitoring tool to be able to correlate our tech metrics and our tech alerts to our billing metrics, so that we're able to see if something happens inside of our billing, like more EC2 spend, more spend on databases, more spend on DynamoDB, all this kind of stuff. How is this correlated to something we're seeing inside of our application and inside of our metrics? And this gives us a great deep dive into what is really happening in our application, but also what kind of cost effect has that for us. So as I said, this is one of our dashboards we're having here. We're using multiple accounts at AWS and consolidate them under one. So on the top left, you see the different accounts, what kind of costs they have. On the top right, you're seeing the different services, which is important to know which are the services you really spend the most or how much do you spend on the different services. And then on the lower row, you have the top spenders on the left side and also the comparison to the last month. And that for us is very, very important because most of the time you will have some kind of a stable baseline. And then you will see something like, okay, nearly all services will cost exactly the same than what it was last month, right? If there's something going wrong, or it might also be good, because if you're scaling things up, then hopefully you earn more money with your application. And then that's totally fine. But those are kind of the triggers we're looking at. Like, why is this service spending more money than it spent last month? And then we could actually look into that, okay, this is correlated to this change in our application, or we just have more requests on our application and stuff like that. So the tip from my side here is really monitor and use those billing metrics that are available inside of CloudWatch. So as you might have seen, EC2 is one of our biggest spenders in our account. And so we're a heavy user of reserved instances. Who doesn't know anything about reserved instances? Awesome. So we actually can go over the slide. You can save 40% with the 1-year reserved instances. You can save 60%. You should look at your baseline, buy those on reserved instances. There are convertible reserved instances. For those who don't know, they were introduced, I think, 1.5 years ago, something like that. And there was a recent change in the convertible reserved instances. They were only available for 3 years. That changed 2 or 3 weeks ago. So you now can also buy convertible reserved instances for 1 year. And that's very, very important if you want to change instance families. And as Konstantin just explained, when the infrastructure gets updated, you will see something like the recent announcement of the C5 family, for example. So if you're now running multiple instances on C4 and you bought the classic or the standard reserved instances, you can't automatically update them to C5. With the convertible reserved instances, you can do exactly that. You can just change those RIs and update them to the C5 family and then upgrade all your instances to the C5 one to get the best out of the AWS flying wheel. So we already talked about the Cost Explorer. This is one of the things, or this is a screenshot out of our Cost Explorer. And as you can see here, most of our instances are really running on standard reserved instances. So we're trying to run the whole application and the whole baseline on reserved instances. And for the excess, so for those things that are changing inside of our application, like scaling out, scaling in things, we're doing on-demand and spot, but we will come to that, back to that later. Talking about reserved instances, there is also a new size flexibility for reserved instances. And as there is so much information in it, I actually read the sentence because it's very important. Within the same family, regional Linux and Unix reserved instances with shared tenancy are instance size flexible now. That means the three important informations here is it needs to be regional, so not availability zone based. So you need to configure the reserved instances to be region-wide available or actually cover the whole region. It needs to be Linux and Unix, so Windows is out of that. And it needs to be shared tenancy. The idea behind the size flexibility is the normalization factor you can see in the table on the right. So if you have an RI, for example, a C44X large, within this RI you already bought, you can now run 2 C42X large instances, or 4 C4X large instances, or half of a C48X large instance. So you don't need to change your standard reserved instance or your convertible reserved instance if you're just changing the size within the same family. You will get the same benefit, like the 40 to 60% out of it, even if the instance size itself doesn't 100% match. You even can buy, if you're scaling up, for example, and you have one of the C44X large reserved instances, as it says in the example, you already covered half of the C48X large. So if you now know, I will run the C48X large for a very long period, you can just buy another C44X large to cover the whole C48X large. I hope that is clear. So this was it from the business side, and now Konstantin will talk about architecture goals.
Yeah, so much for business. So who is involved in architecture here? Come on, okay, that's the meat of the talk. So as an architect, you want to avoid as much waste as possible. You want to architect something that is elegant, that is beautiful, and that doesn't really waste a lot of resources. And the easiest way to do that is to turn off unused instances. And it turns out that a lot of instances are just lying around, spending your money without being used. And those are typically developer test training instances that are just sitting there doing nothing over the weekend or during off hours, right? So these are the easiest low-hanging fruits that you should eliminate. And you can even start and stop them, or you can get rid of them. And actually, one new thing that actually became available last year, or within last year, was that you can now start and stop RDS databases. So you don't have to stick with those databases for 24 hours, 7 days a week. If it's just a development or a testing database, you can shut it down for the weekend or during off hours. Or you can even shut down a whole infrastructure with CloudFormation, which is a great way of automating your infrastructure. So think of instances as something that are disposable, that you just get rid of if you don't need them, and then you conjure up whenever you need them. And here's an example of a very large customer. And you can see here in the instance usage how big of an impact that can have if you are really good at shutting down your non-used instances. You can even make out Mondays and Fridays and weekends and vacations stuff. And in this case, 35% of instance usage can be saved simply by shutting down instances that are no longer used. And the key here is automation, right? So you can automate everything on AWS. You should automate everything on AWS. And you can use the AWS software development kits. You can use the CLI interface or CloudFormation or any other tool. I don't care. The key thing here is have a way to automate the lifecycle of your instances. And that makes it so much easier to then use it for shutting down those instances that are no longer used. And as you can see, you can save 35% easily just by looking at your training and test and development instances. And autoscaling turns out to be a very easy mechanism for having that automation. And your goal should be to use autoscaling as much as possible. I still remember talking to you about autoscaling not that long ago, maybe that was 2 years ago. And he said, yeah, sure, we're thinking about autoscaling, but we are not quite yet there yet. So who is using autoscaling already? Great, but that's still about half of the room. So Marcus, please tell the other half of the room how your journey into autoscaling looked like.
Yeah, as Konstantin said, when we talked about it, we always said, yeah, we're thinking about autoscaling. The problem was we were just thinking about it for a very, very long time. Now we actually migrated over nearly our whole infrastructure to autoscaling group. So as Konstantin mentioned, autoscaling really should always be your goal. I know this is a complex topic and sometimes it's not so easy to reach, but still it should be the goal, and we all need challenges, especially the architectures, right? So the side effect of autoscaling groups are that you just save costs because you can optimize very easily your cost if you are running in autoscaling groups, but we will come to that back later. So our to-dos when we migrated over from those manually hand-cut instances to autoscaling group were the problem of pet versus kettle, the service discovery and our deployment strategy. So let's dive into the pets or kettle. We all like pets, right? So we love our dogs, we love our cats. As you can see on the left side of this picture, we love to pet also our servers in many, many times because it's sometimes much easier just to log into your server and do something because the server needs something. The problem with this approach is that you will change this single server, and if you're now running in autoscaling, that needs to be automated, right? So most of the time when I'm talking to peers and to other AWS customers, every time I see a server named Gandalf the Grey or Gandalf the White or Smeargol or Gollum, I actually can tell, yeah, you're petting your server because those names can't be really automatically generated, right? Kettle is the other approach. Like servers have numbers, servers still have names, and that's totally fine. But we need to have that automated. Everything to set up, start an instance, set up the instance, run the application on the instance, need to be able to automate it in a fully automatic way through autoscaling. So this is is a script we're putting into our user data. With user data, you can use the Cloud Init or CFN Init if you use AWS CloudFormation to actually, in this case, name your service. What we're doing here is that's just a boot command. We take out the availability zone name with the AWS CLI, nothing more than that. Then we do some bash scripting in there. We get out the instance ID from the EC2 metadata. The instance ID is just there because each host name should be unique, and the instance ID is. So we put in the instance ID there. And then we build out with the host name prefix, which is, in our case, most something like the role this instance has, like web server, UI server, API server, stuff like that. And then we put that into the EC2 host name, and we put the name tag in it. So even in our AWS console, or even if we are querying against the EC2 API, we get out reasonable names. The reason why we give out those names and why we, for example, have the availability zone in it is our alerting. Because if we're getting a huge amount of alerts for all the instances that are running in US East 1A, but no alerts in 1B, 1C, 1D, 1E, or even 1F, we actually can see, hey, maybe this is a problem at the AWS side inside of the availability zone. So we can consider that in finding and debugging things, that this might be a bigger problem on the AWS side and not on our side. But if I'm seeing something like instances are going down in 1A, 1C, 1D, and it's always the web servers, then it might be an attack on web servers, for example. And then, so it helps us to understand, based on the host names, what might be the problem before we even look at it. And that's a great thing that we at least like. Let's go to service discovery. Most of you who are working with microservices have the problem, or I assume you don't have the problem now, service discovery. The web server needs to know who is capable of answering API calls, for example. Or the UI server needs to know exactly, okay, this is my API, or this is my database server, or stuff like that. So you need some kind of service discovery, because if you are doing autoscaling, there can be a lot of different instances, and they change all the time. So there is no way of configuring hard-coded inside of a file or whatever. So you need to have some kind of a service around that tells your microservices who there are actually should ask. You can tools like Consul or Netflix Eureka, which are great, or you can just build your own. That's what we did. So we have a scheduled AWS Lambda function, which is just using EC2 tags. We have a tag that is called role, and inside of this role is something like API or database or whatever service. And then this Lambda function just gathers all the internal IP addresses that are used inside of our VPC, and then we put that as an A record inside of Route 53. So we have internal or private zones in Route 53, which then say something like web.internal.mydomain.com. And under this, I get all internal IP addresses I'm using for all the web servers that are live right now and online right now. One thing to mention here, if you build it on your own and you want to use Route 53, there is a limit of 100 IP addresses per A record. So if you're having more instances for one role or one service, you need to be aware of that you need to kind of scale out that. And then last but not least, deployments. Because when you have a fixed cluster or a fixed fleet of instances, it's a lot easier to deploy to them because you know them exactly. But that's what we don't want. We don't want to pet our instances. So we build out a deployment via cloud init at instance launch. So whenever autoscaling triggers an instance launch, we automatically deploy our application to those instances. We're mimicking AWS Code Deploy here, so a lot of awesome ideas inside of the Code Deploy servers, which you can use if you want to, are used here by just using the user data and the AWS CLI for us. So again, this is user data. You can put that on the instance start. And what we're doing here is actually just copying over something that is coming out of the S3 bucket, which is a shell script, and when we pipe that directly to Bash. Be aware, you shouldn't do that, like doing something like a shell script and piping it directly to Bash if you don't own the shell script. So never do that on a GitHub repo or something like that you don't own. As in our case, we own the rtb.sh file here. We know exactly what is running in it. Nobody's able to write to that shell script besides us, so that's fine. What we're doing inside of this shell script is just get our code from an S3 bucket. So our code every time we deploy will be inside of an S3 bucket in a packaged way. We copy that over to the local EBS volume on the instance itself, and then we start the application via systemd. And that's it. And then you actually have a deployment strategy if your autoscaling group starts out the instance. So kind of a wrap up. Why do you use, or why can you actually save money when you're autoscaling? On the one hand, there is this optimized cost through dynamic scale in and scale out. Because autoscaling is capable of triggering based on the CloudWatch metrics if you need more or less instances. So you can just say something like, hey, if my CPU goes above 50%, then scale out. If it goes below 30%, then scale in. You even have the chance to use target now, like telling autoscaling groups, okay, please always try to be at CPU of 50%, and then autoscaling automatically will go out and in. And then there is a new feature on the cost optimization side, which is very, very important, the per second billing. From, I think it was the 2nd of October this year, AWS doesn't measure the billing in hours anymore. Actually, we're down to a per second billing. For autoscaling, that means we can scale down a lot faster now. Because before that change, we always needed to consider that we already paid for the whole hour, right? So starting up an instance and shutting it down after 10 minutes doesn't make any sense because you already paid for the other 50 minutes of the hour. Now, as we are down to the per second billing, we can scale down much faster because you just have the overhead of how much time do I need to start up an instance. And in the end, within the whole deployment, we're at 30 to 60 seconds until an instance is live, hooked into everything, and can deliver content. So we are now trying to scale down within 2 to 3 minutes if we need to. You also can leverage scheduled scaling events. So if you know something like Konstantin just said, the developer instances, if you have developers that work on weekends, awesome. If not, then you might want to leverage scheduling scaling events. If they come to the office at 8 o'clock on Monday, but I assume no developer will be there at 8 o'clock. So let's say 10 o'clock. 10 o'clock a.m., you can scale out the auto-scaling group of developer instance. And then you can scale down in the evening, like 10 p.m., for example. And then you can scale out and scale in on a daily basis. So you can schedule those scale in and scale out events within the auto-scaling groups. You don't need to trigger any Lambda function or whatever. AWS covers that. And then last but not least, if you are using auto-scaling, it's very, very easy to actually switch now from on-demand instances or reserved instances to spot instances. The reason is that you always have in mind now that auto-scaling might scale out or even scale in. And then it's the perfect point in time to actually switch over to spot instances. And Konstantin will now tell about spot instances and why is it that.
Cool, yeah. So who's using spot instances already? Cool. Cool. So who has been here in this talk last year? You already heard about spot instances. Why are you not using them already? So what are spot instances? Spot instances, remember, large infrastructure means AWS keeps some overhead of infrastructure that is actually not used by customers because we need to be prepared for launching an instance at the whim of any customer anytime. So that means we keep a large overhead of instances that are not used at the moment. So what do? We sell those instances on the spot market. Just like at Wall Street, you can bid for an instance. You can say, hey, AWS, I know you have those instances lying around doing nothing. I'm prepared to give you 10 cents for that instance, even though the normal on-demand price would be like $1 or so, right? So you can actually bid your own price for our unused capacity. And the nice thing is you don't pay for the price that you bid. You pay for a price that is computed based on supply and demand. So if you have a lot of capacity that we don't use and not a lot of people bidding against that, you can get away with a very, very, very low price because you're outbidding everybody else, even with a low price, and there's a lot of supply. But on the other hand, what happens if supply becomes thinner and thinner and thinner? We have to take back our spot instances from the market. So that means that you need to be prepared for the spot instance to be terminated for you because we have found a higher bidder for that instance, right? The good news here is you get a 2-minute notice before that. So there's an API call. You can call the API, and it'll tell you, OK, this instance is to be terminated in about 2 minutes. Clean up, save your stuff, and go away. And that gives you the opportunity to react to that. So the best way here is you can simply use an auto-scaling group, right? But a new thing that we introduced only in the last couple of months is instead of having your instance terminated and losing all your data, you can simply choose to have your instance merely stopped. And then you can continue once that instance type becomes cheaper again. Great flexibility, especially for batch jobs. And the other thing is you should always plan for an unscheduled maintenance, for an unscheduled loss of instances, because hardware does still break, right? So the best way to do that is to write an application that automatically can install itself using scripting, and then use an auto-scaling group. Here's how the pricing looks like. And as you can see, the pricing for spot instances looks pretty dynamic, right? This is an example with an on-demand price of 34 cents to the dollar. And you can see that there are times where the price is actually 10 times higher. And that is because many people are overbidding each other and saying, OK, I'm fine paying 10 times the normal price if I just get to keep my instance, because I know the price is going to go down anyway, because you can look at the spot history. But the other thing you can see is that the price can drop down to 11 cents here in this example to 34%. This is lower than reserved instances. And in some cases, the price can drop as low as 10% of on demand. So there's huge opportunity here if you know how to leverage spot instances. So here are some use cases that work really well with spot instances. Anything that looks like a stateless web application server fleet, that's fine to use with spot. We have customers who are running exclusively on spot instances because a real web application is built against failure, and there is no difference to the web application whether you're losing your instance because of a spot instance pricing event or whether you're losing that instance because of a hardware event, right? You can use spot instances with Amazon Elastic MapReduce for Hadoop jobs and save a lot of time, a lot of money there. You can use them for your continuous integration thing. Basically, anything that looks like a batch fleet of instances can leverage spot instances. And you can then choose to use two auto-scaling group, one with spot instances that is used by default, and another one for backup. If the spot instance trick doesn't work for you because the pricing is off, then the other auto-scaling group with on-demand and reserved instance can kick in and compensate for the loss of instance capacity. There's another thing you can use. There's a spot bid advisor on our website, and the spot bid advisor will tell you, based on the history of spot instances and based on your particular price that you're willing to pay, what the likelihood is that you're going to keep the instance for that specific time. And whenever you see a low here, it means that for a full month, that instance would not have been lost to spot, right? So just a quick recap here. Spot instances give you dynamic pricing, which is a great opportunity for you. You can save up to 80 or 90% cost. Those prices can vary per availability zone. So you can use something like spot fleets that will give you the opportunity to say, okay, I don't care where my instance is. I don't care what availability zone. Here are the 3, 4, 5, 7 instance types I'm prepared to use. Just find the cheapest one and go and run with it. And the other cool thing about spot fleets is you can manage thousands of spot instances with a single API call. And this is great for batch jobs and for running compute grids and AI simulations, whatever. You can do that with spot instances very, very cheaply. Now, some customers say, okay, I get it, Konstantin, but I have applications that are so small, even the smallest AWS instance is still idling a long time because it's just a really simple thing that I'm doing here. And if you're running a lot of small applications and all of them have their own instance, you should be leveraging something like EC2 Container Service and put them into Docker containers. So you're probably familiar with EC2 Container Service. It has been around for a while now. And the thing to do here is try and find those single instances doing some simple job out there, but that are still idling at 10% or 12% or whatever percent, and consolidate them into a smaller amount of instances running EC2 Container Service. So the benefit here is, instead of having those individual machines there, you can put them together into a smaller number of machines, and Docker allows you to run multiple applications side by side within the same instance, and that's another way of saving money. But of course, Docker containers, it's kind of like last decade or so. The new thing is Lambda and serverless, right? So who is using Lambda already? Oh, cool. So you can even save money with Lambda. And it turns out that if your existing application is only seeing about 40% utilization or less, then you can port it to Lambda and save money compared to running the same application on an EC2 instance. So that is a good rule of thumb. If you're seeing an application that is not enough to fill out your server capacity, try bringing it into Lambda. But the other thing you should do is you should be smart about your Lambda functions. And by smart, I mean you should keep track of how much Lambda capacity is really computing and how much is waiting. So here's an example Lambda function. So many Lambda functions look like this. You're calling an API and you're waiting for its response, and then you're calling the next API, and then you're waiting for another response, and then you're taking all of these responses, doing something interesting, and then you do an HTTP post or whatever in the end. And notice those gray areas in this timeline graph here. These are the areas where your application is waiting for that API call to complete. And that period is compute time in Lambda that you're paying for. So you're paying for Lambda doing nothing during those gray areas. So how do you optimize? Well, many times these Lambda functions, they call API A, B, C, and D, and then they do their actual work. So you can parallelize here. So you can multi-thread within a Lambda function, call all of these 6 APIs right away after all, wait a small amount of time because they are now working in parallel, and then collect all the results and be done earlier. And that is a great opportunity. So when I write a Lambda function that is performing multiple things, I always write it in multiple threads, and I gain because my Lambda function is going to be faster, and I will also save money here. Don't overdo it. So I actually started in the Lambda function, I started 20 threads, and I fired all of these 20 threads in parallel to an API that was not running on AWS, and then I got an email from that API owner that I apparently broke that API. So tough luck. I told him about API gateway and all the good stuff here, so let's see. But it's a great way to save money. And all of those languages have some form of capability to multi-thread here. The other thing here is I see many Lambda functions that actually act like a shepherding thing, like they are doing something, like starting a job, and then they actually explicitly wait with a time.sleep call or something because they know, okay, I just started this job, gonna wait until it's over, and then I'm gonna be done with it, right? And that is a big waste of money, big waste of Lambda money. You can do the same now with step functions. So AWS Step Functions is a service that we introduced last year that allows you to place control logic in the cloud as a step functions workflow. And in the step functions work, you can start you can submit your job at the beginning of that step functions workflow, and then you can implement a simple looping logic that will poll for the job to be completed, and if it's not completed, do the waiting for you. And waiting in step functions is for free. You don't pay for wait cycles on step functions. You can wait for seconds, hours, weeks, even up to a year without paying anything for the wait time. So by decomposing that Lambda function and putting it into a step functions workflow and just using a simple Lambda function to submit the job and one at the end to collect the results, you can save a lot of money. How much money? Well, here's a customer called Coca-Cola, and they have a system where whenever you buy a bottle on their machines, they will update your loyalty points account. So they'll give you like a rebate if you drink so many bottles of Coca-Cola and stuff like that, and there's an update there. It turns out that this update thing needs to wait for 60 seconds. And they really waited, no, actually 90 seconds. So they really waited those 90 seconds within the Lambda function. And then a colleague of mine told them, okay, you can do the same with step functions. And now they are saving a lot of money for each. They're saving 90 seconds for each individual bottle sold out of those machines. That can add up to a lot here. So there's a blog post about that. You can read it up here. And great way to save money by optimizing your Lambda functions. Okay, let's get down to the core of your application, which is the database. And Marcus is an expert in database optimization. Yesterday we had a talk around caching, remember?
Yeah.
And now he's going to tell you how to save money with databases.
Thank you. Yeah, I think databases are a great part of how to optimize your costs, because databases on the one hand are very complex, but sometimes they're very expensive. So caching helps nearly all the time for that. In this case, it's a pretty simple example. We have an application that is directly talking to Amazon DynamoDB and Amazon RDS. And we put just a simple Amazon Elastic Cache, in our case Redis node, in between. So every time we're asking our database, we now ask first our cache if there's something in the cache. If it is, then we don't need to ask our database. If there is not, then obviously we need to go back to our database and save it later on in the cache. We implemented this Redis node in our application or in the architecture, and this is what happened. So I think it's pretty obvious where we deployed the cache, and those are our DynamoDB reads. So for those who don't know, DynamoDB is actually priced per provision throughput. So we could go down for this particular table with 3,000 reads per second less than what we were doing before. Overall, in our whole cluster, we're actually saving or save more than 20,000 reads per second in total. That adds up to multiple $1,000 every month by just one single Redis node, which costs you something like $150 to $200 a month. So that will pay the next reInvent, right? Only this. But talking about caching, there is one thing I really want to emphasize here, because even if you just saw this incredible example of, hey, this will save me money, even if with those numbers we forgot something. We forgot about negative caching. And when I say negative caching, what I mean is that very often we ask our database, like, hey, please give me, in our case, the highest bid for this particular query. And then our database says, I don't have anything in here. No object, no document, no row, whatever. And that's a total valid answer, and that's totally OK. But our application had something like, if database result, then save to cache. Unfortunately, we're working in Node.js, so it's not type safe. You all know the drill. If nothing, then we don't save to the cache, right? So the problem was we didn't save this very valuable information of there is nothing in our database in DynamoDB. And so all the time for the same query where we actually already knew that there will be nothing in it, we again asked DynamoDB. So when we implemented negative caching, so just saving the information of there is no result for this query to Redis, our cache hit ratio went up from 25 to 30% up to 89 to 95%. So actually, with this very small change in our application and with actually accepting and seeing that even if in a no result, there is valuable information in it that should be cached, we save, again, multiple $1,000s every month. So that was simple for the next 10 years of reInvent, right? But it's not only about caching. You also can optimize a lot of things inside of DynamoDB. And Konstantin is the specialist for that.
Oh, yeah. So check out the DynamoDB documentation. There's a whole section on best practices here. You can optimize the capacity usage use. Note that there are different capacity units, whether you read or write. So read capacity can be 4K per unit, but the write capacity is 1K size here. So you can optimize that by optimizing for more reads and less writes or something like that. Another neat trick here that was pioneered by Shazam is if you want to be cheap on write capacity, you can bring down the write capacity of your DynamoDB tables to the absolute minimum of your average capacity that you need. And that means that during peaks, you will see out of capacity errors from DynamoDB. And the way to handle those is to write the amount, the thing you want to write into an SQS queue and have a small worker, like a Lambda function that is called every minute, that will try and redo those writes, that retry those writes against the DynamoDB. And that means that when the DynamoDB load is going down again and it is a little bit more relaxed, then it can accept those writes. So that allows you to scale down write capacity and only update those writes when there is enough capacity there and get away with setting the write capacity to the normal average capacity. Doesn't work for all use cases. I wouldn't implement your bank account balance with that one. But many times you can actually be a little bit more creative in how consistent you want to be with some tables. And then Amazon SQS is a great way to buffer writes. Think of it as inverse caching. Like in the same way you can save through caching for reads, you can save through buffering an SQS for writes. And the other thing is, those capacity units are not set in stone. Before, you would need to resize them dynamically on your own, and now there is autoscaling. You can use autoscaling for DynamoDB. You can simply plug in what is your read and write capacity autoscaling settings, and everything else is done by DynamoDB. And here's a look at a graph on how it can look like. The blue line is the actual consumed capacity, and the red line tells you the capacity that was provisioned using autoscaling. You can see how it automatically steps up. And to overcome those phases where it has not yet updated the capacity it needed, this is where you can leverage caching or write buffering through SQS. Another way to save capacity and money, and another way to cache, is by offloading popular traffic on the web side, on the HTTP side, to Amazon S3 for static content and to Amazon CloudFront. And even if you think that your content cannot be cached, there is so much value in just caching something for just a single second. And the line between this is super super dynamic content which changes all the time, and this is something that can be cached. It's kind of blurry. Even if you run the most actual news site that does everything super lightning speed fast, even if you put a TTL of 0 into your HTTP response, you will save through caching, because CloudFront will ask the origin server, hey, I have this piece of data that I cached. Did it update yet? Through an HTTP head request. And then your application will say, no, no, it hasn't been updated. It's still that way. Don't worry. And then you save on that transaction, and you save money. You save on capacity, because now CloudFront knows I can still use that cached copy because I know it hasn't changed, and then go use it off. So even if you think you cannot cache, try to use CloudFront with a TTL of 0, and you will see that there's going to be some significant load that you can carry through CloudFront. And that means you can scale down your backend because it will see less load and more being served by CloudFront. Okay, let's move on to the operational people here. Some people still distinguish between dev and ops, or maybe you do both. But the key here from an operational perspective here, and that is something that is at the core of AWS, we are in the business of helping you concentrate your own efforts into the thing that your company stands for. We don't want you to reinvent the wheel on the IT side. We want you to innovate for your customers. We want you to innovate on your business models to create something new where your intellectual property is. And we don't want you to become experts at something that can easily be automated away. And that means focus on what you do best and let AWS do the rest. And that is another exercise that Marcus has made with his own team here. When we started, he was running his own database clusters and all that other stuff, and he was actually the local leader for the user group, and now he gave up on that. He's now concentrating on what his company does best.
Thank you, Konstantin. Yeah, in the end, we accepted at some point that we can do things very, very good, but that wasn't running databases, and it's still the case. So even if we learned a lot about databases, if we could run them, it always was painful. And so we decided that why not using the AWS services, which are there. And when we started to migrating over more and more things to the different AWS services out there, we recognized that it's not only about just use the AWS services because they're there, and AWS has the expert for every single service because that's what they do 24/7. And I think that's why they're selling it. We now try to figure really out what are the real needs of our application for this very single purpose we are now thinking about. And then we decide which service is actually the best to do that. We couldn't do that before because, and I think that sounds familiar for many of you, we already have that database. The data needs to be in there because it's already there. And that makes sense in the old world of where we have these huge clusters running on bare metal, because the overhead of maintaining and operating those things is not to underestimate. So here the answer is totally valid to say that. But today, when we are running inside of AWS, AWS takes away this whole operational overhead. We don't maintain databases anymore. We don't need to maintain queuing systems anymore because there's SQS. We have the Elasticsearch service. We can use Kinesis, all those streaming services, all those very awesome services which are actually customized for the different use cases we have. But even if you are already using a service, like in our case, Amazon EMR, we used it to do queries on a huge amount of data. And then, I think it was last year at reInvent, Amazon Athena came out. And so we thought, hey, maybe we want to try something out here, because running Amazon EMR and doing query against it worked for us. Was totally fine. But we just did the test of, hey, can we do the same with Athena, and maybe that's more cost effective? And it was. Because for us, the startup phase of EMR was very, very crucial. So the startup phase took a very long time. We did something not so intelligent in there, to be honest. But with Athena now, we don't need to maintain the EMR clusters. We don't need to touch instances anymore. And as the slide says, our costs are down by more than 50%. But as I said, this is a very special use case for ours. But this is more about trying things out. On AWS is so easy because you can just do it in parallel for a week or 2 or a month or 3 months, something like that, to see does that work what I thought of, and then switch over to the more cost-efficient solution. But talking about services, talking about pushing things away to AWS and let they do the job. As Konstantin mentioned, we had this application which was actually divided in a tracking API, a real-time bidding engine, and a user and statistics API. And then we had the self-managed database. Running on EC2, we need to maintain the database by ourselves, but that wasn't really the biggest issue. The problem, as we now know a few years later, was that our architecture wasn't really split out into the several things that our application does. So the more important things about this migration over to DynamoDB, Amazon Aurora, and Amazon Redshift is not that we just use the services now. That's a big benefit. But the most important point here is that now our application is actually split out in different stacks. And the stack does include the database. So for every single purpose inside of our application, we are now using different databases, different database clusters. If you're using a DynamoDB table, for example, in the reality, it's a database cluster because it gets synced over at least 3 availability zones. There are multiple instances running behind the scenes. Same with Amazon Aurora, same with Amazon Redshift. So in the end, we split out our architecture step by step, and now we can pick the right tool for every job we have, because there are so many different databases and other AWS services out there. And actually, the challenge now is to find the service that is the best suitable for the job you want to have. Those are just examples. There are many more of them. DynamoDB, the key value store with scalable throughput. So whenever I actually want to be built by read or by write, which makes sense in a lot of cases, I want to choose DynamoDB. Low latency, we all know that. Amazon Aurora, if you want to have a relational database, but you want to have scalable storage. Because Amazon Aurora automatically scales up and down on the storage side. You always pay for what you use, and then you have an instance on top with multiple read replicas, for example. Amazon Redshift for the higher latency but big data, and then ElastiCache, as already mentioned, for caching, but also for more ephemeral data that don't need to be that durable. So for us now, the key is that we're always thinking in stacks. And every stack is an own architecture. So we're not thinking about this whole application, and we don't even think in microservices, because even inside of a microservice, there can be multiple stacks, because there can be something that is write heavy and the other part is read heavy. Those are different stacks for us now, because they have different considerations you need to do there, and so we choose different tools, different databases. You have unstructured data versus structured data, or, as Konstantin already mentioned, you have consistent load versus inconsistent load. Some databases are very good in actually handling inconsistent load. Other databases are very, very good in handling consistent load, so you should choose on that. On the cost side, as this is a cost optimization talk, interesting enough, if you just look at the pricing page, for example, for Amazon Aurora, if you look at the price for a DB R3 large, that's exactly the half of a DB R3 X large. Large versus X large is exactly double everything. Memory, CPU, all this kind of stuff. So in the end, why running the bigger one for multiple microservice or multiple things if I can run 2 for exactly the same price? And that gives me, in the end, a lot of advantages. On the one hand, obvious, no undifferentiated heavy lifting. AWS does the job for us. That saves money and work, or it saves work, and that's why it saves money. We don't own our databases anymore. Own is the wrong word. We don't manage them anymore, because AWS handles the whole database infrastructure for us now. The benefit now, also from a cost perspective, is we have a more granular scale out now because we're scaling only that stack that needs to be scaled. We don't need to scale this one huge database where everything is going in and out. We just scale that part of our whole application that needs the scaling. And that obviously is a lot more cost effective than if you scale the whole cluster. We have absolutely no interference between the different functionalities and systems now. If something happens with one system, the impact on the whole system or the whole architecture is a lot smaller now because everything is an own stack now, which is totally separated from each other. And one nice side effect of everything, what I just said, is the issue pinpointing and the team responsibility is a lot easier now. Because if something is going on in one database, we know exactly the source is this part of the application. This is where we need to look at. This is where we need to debug things. This is where we need to scale against. And that makes things a lot easier, especially if you have different teams for the different stacks, because then they can really own the whole stack and they don't have to rely on operations underneath it. And that was it for me. And Konstantin does a recap.
Thank you. So we are reaching the end of our talk here. Let's recap a bit. So first of all, get that cost transparency by looking at the TCO tool, the billing tools, and all that other stuff. Use reserved instances. That is the easiest way to save money. Avoid idle instances through automation. Use spot instances if you don't do that already. Think about the database utilization and optimization techniques that we learned about, and try to pick the right tool for the job. I don't want anybody putting log files, application logs into MySQL databases right next to their high-volume transaction systems. And I've seen that before. And offload your architecture by using caching, CloudFront, and stuff like that. If you're still unsure where to start, you can get a hint from AWS Trusted Advisor. Trusted Advisor includes a report that will tell you, here are some great cost-saving opportunities. And you get Trusted Advisor for free if you have business or enterprise support. If you like this talk, you can actually check out our previous talks on YouTube. So you can find last year's and the year before that. Every year, we optimize our talk. We listen to the feedback. We change and swap out back and forth. So you will find new stuff to optimize for in the older versions of our talk. And if you like this talk, feel free to give us a good rating, and then we might be here next year again. So thank you very much.